Hi everyone, it's Dr. Ahmed Mahmoud. I'm a research associate at the University of Leicester, and I'm part of the Endangered Archaeology in the Middle East and North Africa project. So I will be quickly demonstrating how to use the EAMENA machine learning automated change detection tool, which is a tool that is developed in Google Earth Engine, the cloud computing service of Google Earth Engine. And this tool has been developed by MENA Leicester team to monitor disturbances and threats to heritage sites using satellite images and remote sensing. Um, so we have developed this training documentation that you can go through. So it will take you step by step on how to use the tool and how to prepare the tool and your script to automatically detect the heritage sites. So the tool uses um, um, Google Earth Engine as a cloud computing service to access satellite images of Sentinel-2 and processes these satellite images using random forest algorithm to classify these images into land cover classification maps, and from these land classification maps and images, it can detect changes and threats to archaeological sites over time. Um, so in this video, it's going to be a very quick video, and I will try to demonstrate how to use the tool. So I would assume that this is a code for a case study that is already prepared and preset. So the case study here will be manually case study, and this is the link to access the script for this uh, code. So if you click here, it will take you to um, the Google Earth Engine Cloud code editor, and you can view the script on Google Earth Engine. Um, so so as I said, this is just a demonstration for this specific case study and how to use. I'm going to show you how to use the tool, and also I'm going to show you the user interface. So first of all, let's assume that you have many scripts in your script folder here. So you can just press and click on the script that you want to execute. So assuming that you developed this script or you updated and adapted the main original machine learning ACD script to your new case study. So once you click on the script here, it will appear on the code editor, and then you can click on the main run button here to execute all the um, codes and scripts that you have line of program lines that you have here on the code editor. So as you can see, once I clicked on the run button here, a user interface appeared on the left, which describes the tool, the monitoring archaeological site tool, um, and all the steps that I will be taking you through one by one. As I previously mentioned in our previous recording, that this is the main script that has been developed um, to automate the process of detecting changes and threats in heritage sites using remote sensing. Um, so So I would again assume that this is a script that is already prepared with all the inputs, as you can see from the our training documentation, that to start with using the machine learning automated trend detection tool, we need to set, there is three main stages actually. The first one, which is defining variables and inputs, and this includes defining the study area, the archaeological sites under investigation, the training samples, and then the visualization parameters and name of and values of inputs. Of the outputs that we want at the end. So presuming that we already define and did this stage, and we want to just execute the analysis using the user interface, the machine learning ACD user interface to process and do the image classification analysis, then the identification of threats on archaeological sites. So if I go back to the main script, you can see that the first state or the first step here is to define the start and end date of the study period that we want to investigate. So for example, if we want to, in our study area, we want to see changes and detect changes that happen between 2020, 2020, 1st of January, up to 2024, July 1st. And then the second step that we need to define is the feature buffer distance. And in this case, it's the, we can set, for example, 50 meters as a buffer, 50 or 60 or 100, or it depends on your case study. So it will be the buffer for your heritage sites. And then once you click run, this run button here, which is which is the third step in the executing the machine learning ACD automated change detection tool, and it will execute the first stage of the processing of the code or script that we had on the code editor. As you can see, sometimes because I've selected a very long study period of about 4 years time series of satellite images. So that means the number of satellite images that will be selected or filtered will be large, and this sometimes it might cause the tool to, as you can see, these messages here saying that the page is unresponsive. But if you can just press wait and wait a little bit for it, it will execute the first stage, and then it will provide some, as you can see now, some additional tabs or panels where you can continue the following steps. So, so as you can see here, now it says that we need in the fourth step is to select year for training data. And by the year of training data, that means if we go back actually to the training documentation, we will find how to do that part. Basically, the training samples that we collected representing the different land cover features that we see on the ground will. So these training samples must be collected in a specific year. This could be, or this could be corresponding to some ground field surveys that you did to collect ground truth data. So these images, it should be the same year as the collection year of these training samples. And there is Specifically, you can get more details on how to collect training samples and how to also set the date for the training data. So this is the step that you can see here. So what will happen is that once, for example, because I said our analysis is between 2020 and 2024. So for example, let's say that my training samples, which are the bare soil, mountain, quarry, urban, and vegetation. So these are the 5 land cover classes that I have in my study area. So these training samples were, let's say that they were collected on the 2020, then I will select 2020 as my training data. So once I do that, you can see that it's actually now selecting only training image collection, which is only for 2020. So basically, it's the machine learning model or the machine learning algorithm will train on the images that were acquired in 2020 within the area of Bani Walid. On the console here, you can see some results as well that we talked about previously, and I'm not gonna talk too much about it here, but it includes the Sentinel-2 filtered images that we have. So we have about 122 images that were filtered for the study period between 2020 and 2024. So if we go back here to the user interface again, we can see that for the 50th step, it says choose your image dates. And again, this is, you can see from the drop-down menus that we have here, it says select first image, select second image. So these are 2 images that we want to understand what type of changes that occur between them. So for example, let's say we're going to select the first image, and then we're going to compare it with another image from maybe, let's say, this one here in 2024. So the 6th step, it says press the second run button to execute the second stage of the processing. So and this is actually the second stage, which includes the image classification and analysis of these satellite images, and also in preparation for the identification of threats on archaeological sites in the 3rd step. So once I press on that, you can see that on the console here, new outputs appear, which includes the classifier matrices, including confusion matrix, overall accuracy, the kappa coefficient, the producer and user accuracies, and also the F-score. So all these accuracy accuracy statistics, it kind of provide how information about how well enough the classifier is managing the classification, or how accurate the classifier is, and how good the classifier in detecting and classifying the different types of land cover based on the training data set that it was trained on. You can see also some results here that appear on the layers tab, which includes different type of data, including, for example, the sites. So now we know the sites in our study area. So I can just flick to the satellite. There is, for example, the first image which we selected, which is the 20th of January 2020. And then the second image as well, we can view the second Sentinel-2 image, which is this one. So you can clearly see that there is some significant changes that occurred either on the Wadi of Beni Walid or here on this area, and also in some urban expansion that has happened as well. We can view different type of results in terms of image differences, NDVI for those two images, but most importantly, the classification images for the two selected dates. So we can see that because this actually was the growing season in that part of Libya. And so we can see that vegetation is quite and specifically in that year, the vegetation is quite presence of vegetation is quite significant. So if I can just flip between them, you can see some of the changes, and but indeed there is some misclassification that you can see here. And again, this might be because of the year that we selected for training data and how accurate that was in terms of the collected training samples. Was it corresponding to the same year, or was it collected on a different year, which will have some implications on the classification as well. There is this binary change map that you can see as well here. Red areas with change, blue area, black areas with no change, and so on. And there is also the change classification map, which is basically comparing these two classified images, the first classified image and the second classified image, and identifying, as you can see from the legend here, the change detection. So areas that change from bare soil to mountain, bare soil to urban, or bare soil to vegetation, and so on. So and again, actually one of the things that you need to be also considering is that, for example, mountains here, most of the time, unless there was like significant coring activities like bulldozing or some significant work in the area, these mountains must not change. So that is something that you also need to take into consideration when you are defining your classification or classes or land cover classes. So if I go back to the console here, you can see that there is, we can see the confusion matrix. We can see the overall accuracy of our classifier. How did the classifier, did it work well? Which are the areas that or samples that we need to work on? For example, here there is overlap between urban and bare soil, so which is something that we will probably expect to see. If you press on the land cover classification, our aerial time series, we get our aerial time series for which will show the general overview of how these areas change over time and how the different land cover classes change over time. I guess one important thing to also talk about, which is the seventh stage 7, which is the change detection analysis. So it says like select change type. So if you if you are interested in seeing, for example, here areas that change from bare to query, for example, which is the activity of querying here, and then you press on Analyze Selected Chain. Then two additional layers will appear here on the Layer tab. The first one will include the pixels or a raster for areas that change from bare to query, and then a shape file or a feature collection that will show areas that heritage sites and the threat of bare to query between these two dates. Again, by clicking on that, also some of the results we will see it here on the layers tab, but also some of the results will appear on the console once it's done. So, for example, it says that the number of heritage sites impacted by bare to query are five sites, and you can see some of these pixels here. I would have imagined to see some of them here and I guess I can see some of that actually here on the querying activity area, which is the expansion. And we can see the expansion of the querying area into the heritage site of in this area. Right. Let's wait for it a little bit, and then it will show here. Okay. So what we will have is that we will have a buffer or side buffer, such like this one in this area, showing the yeah, that's the one. So it's a site that is impacted by or seeing some of the expansion of the coring activity. Again, I think one important feature that we added is the excuse me, is selecting or generating a chart for a classification time series chart. So, for example, if I'm interested in seeing what happened in terms of in this specific site, so this is an old settlement in the area of Bani Walid. So, for example, if I know that this is specific building is very close to the to the or I can give more good example actually by where we can see, for example, here. So we can see that there is some construction of new buildings. So, for example, and also some trees and maybe some burning of some dump or trash. So if I click on this building here, a new point will appear here on the layers tab. So it says point location 1. And if I go back to the console, I can see that classification chart is being generated, and this chart will show me the changes in this specific location, whether this location has been classified as urban or either this location changed over time from bare soil, for example, into urban, or it remained as urban since 2020 up to 2024. So basically, you get these chart classification change charts. So that might take a while depending on the images that we have. However, in general, that is the idea of generating these classification charts. So while I'm waiting for that one, I can just show you that on the task tab, you can export any of the results that you want to use. For example, if you want to export it and use it in QGIS, or if you want to use it in any other GIS software, for example, then you can do so. So for example, if I want to export the classification changes, then I can do that and save it and give it a coordinate reference and so on. And then I will click run, and then it will execute that and save it there. So for example, this is the results. This is the generated classification time series. And it says that this location used to be urban, and then probably these spikes here, and these are probably misclassified images, so there or pixels in this specific location, and so on. So if I want to continue generating some, if I want to generate some other charts, then I will just click on the location, either using the pan as it is, or this hand here, or I can just click on inspector, and then I will get this crosshair, and then I can click on more specifically on a specific location. So that could be also another option. So I've clicked on this one, and it's generating another chart for this second location. And you can see that it says point location 2. Again, so if you want to do more change detection analysis, you can, for example, change the change detection or the threat or change that you are interested in seeing. So for example, if I want to see areas that change from vegetation to urban, for example, there I have like agricultural fields that new development happened in the area, and it kind of encroached into these agricultural areas. So then I can press and analyze selected change, and then I will get again new change areas in terms of a raster, and then I will get also a new shapefile for the sites impacted by vegetation to urban. So this is my second chart. So this is the second chart that I've had, which was basically in an area where there is a coring activity as well, or some earth disturbance. So I guess that's everything for this video. I just wanted to kind of show you how to use the EAMENA machine learning automated change detection tool, and also I think one more thing to kind of also mention is that you can access and look for updates on the EAMENA machine learning ACD GitHub repository, or you can just look into our EAMENA project GitHub repository. Under that, you will find the machine learning ACD, and then you will find the latest training documentation in English and in Arabic, and you can also find the latest version of the script as well, if that is not updated on the training documentation. I believe that is everything for this part of the demonstration, and I will be recording another video about how to adapt the EAMENA machine learning automated change detection tool for your own case study. Thank you very much for listening.